All right, so before I start the demo, I have a couple comments. One is the application is delivered via web browser. It doesn't necessarily mean that it's stored in the cloud. It can be on-premise, hybrid, or in the cloud, but the user accesses it via the web browser. It's zero footprint, which means you don't have to install any software, any plugin, or anything. The other comment is that the system is roles-based, which means if you access as a radiologist, you see something different than if you access a pathologist or a geneticist. So in this case, I'm going to access as administrator, and that way I can show you everything at once. I don't have to log in and out to show you different functions. As you can see, there are many options, many functionalities, many modules, and it will take hours to go through the whole thing. So, but any regular user will only see 4 buttons. You know, if you're a radiologist, or if you're a pathologist, if you're an oncologist, you're not going to see all these things. You're going to see very few, which are going to be the ones that you need to work. So in this case, what I'm going to do is, instead of showing you the regular workflow, you know, you first schedule a patient, then the procedure is performed, then is reviewed, then is reported, blah, blah, blah. I'm going to show you the very end of the process, which is where all the information comes together, which is what makes our system particularly useful. So in this case, we'll be here, and this is going to give you a list of patients. Now, those patients can be, if you're an oncologist, it can be the list of patients' visits that you have today, or it could, if you're in a molecular tumor board, it could be a list of cases that need review. You know, so depending on who you are, this list means one thing or another. But in any case, these are patients. So what we do is we select one patient, and the system pulls up information. This first screen of information, this demographic information, it's only for verification purposes. So this is pulled from an electronic medical record, and here basically we can check for birthday, check for allergies, check for stuff, or make corrections if there are mistakes. So we make sure that is the right patient. If the patient is hospitalized, it will show you a barcode, like, you know, the barcodes that they have in hospitalization bracelets, or, you know, if you want to check, you know, what the insurance, or see if there's additional files, or add additional files to the patient file, you can do it here. But in any case, this is just for checking. And then when you go to studies, this is what sets us apart, which is a patient-centric view, a 360 view, if you like, of the patient, of all the things that that the system has on the patient in an interactive way. So if you have external files, they'll be shown here. If you have biosensors machines giving data, discrete data on the patient, like pulse oximeters, temperature, whatever, they can be shown here. Now, we do not recommend this module because each of those machines have a different driver, quite often a license, a payment, and it could become very expensive to try to do this in a hospital. We recommend to talk with companies like Capsule that IBM bought, that has all the drivers for the machines. So if you're interested in this, beware that it's complex, that it's expensive, that it's time consuming, but it can be done. So I'm just showing it to you for that reason. So the most common areas are, for example, we start with radiology, and we open radiology, and what we see is read-only report. Later I'll show you where the reports are made with voice recognition, templates, and all that. This is read-only. I can see the keywords and who signed this report, and then the viewer. Now, the viewer can be anyone's. It can be ACFA's, it can be GE's, it can be Philips. You know, it doesn't matter. This is our viewer, but it could be any other. As a matter of fact, we have other viewers. And if you have time, I can show you the latest viewer. But the point is, we see on the left the studies, and those studies can be all of the studies for the patient. It can be the studies from the last 4 months or studies marked as, I don't know, oncology. So what studies are shown, that's determining in the administration and the configuration. But anyways, we have the studies there and we review. So we've seen in the report, okay, I'm going to play doctor. I'm not a doctor, so I'm just going to make up stuff. And let's say I'm an oncologist. And we've seen in the report that they say there's a tumor. I say, oh, see, yeah, I see there's a tumor here. Is there a biopsy? Is there a pathology view of this tumor? So I can exit radiology, I can open pathology, I see cytologies, biopsies. I select one, and in the same place, I find the report. And the previous report might have been a DICOM structure report. This report might have been a Word or a PDF document, living in a completely different silo database folder. But to me, it doesn't matter. I access them all with the click of a button, and they're in a format and in a place that I can find it easy. And then we have the viewer. This is the pathology viewer. Pathology viewers are different from radiology viewer, even if you're using DICOM now. None of the digital pathology scanner manufacturers offer DICOM output. Some of them are working on it. Hamamatsu is about to launch one that does. So we'll get there, but right now they don't offer DICOM as an output. But we do DICOMize the output of all those scanners, all those different file formats. So we have a DICOM image. Now, why does the viewer have to be different? Why can't it be the other viewer? Well, radiology works in slices, and pathology works in C-levels. So if you throw a DICOM pathology image to a classical radiology viewer, it's going to try to interpret sizes. It won't be able to, so it will only take one layer, if you will, of the pyramid, and will not be able to show the rest. If you try to navigate, it will optically zoom in, which will pixelate the image. And as you can see, that's the last thing you want to do in pathology, because as you zoom in, there is a lot of information. Then it needs full resolution. So that's what we have here. We have a viewer that works in C-levels, and pathologists work in a very different way from radiologists. Radiologists know exactly what they're looking at because it's an anatomy. So even though I can't tell the difference between a wrist and a knee, radiologists can very easily. So what pathologists do is they move up and down, left and right all the time. So they're looking for anomalies. They're looking for specific keys, specific things in the image that can tell them if something fishy is going on. For example, you can see that most of the structures here are very similar. When we go here, the structures change. And this could be inflamed cells. This could be fat cells. So I'm not a pathologist, I can't tell. I think these are fat cells in this case, but this is the kind of aha moment in a pathologist that they found from moving around. Now, the thing with most, and the reason why I'm showing you this is not only to show you how pathologists work, but also I've been clicking left and right, up and down, different zoom levels all the time. And that's because that's how pathologists work. Now, if you do that, and I'm going to continue doing it as we talk, if we do that in any other system from our competitors, eventually the system crashes. The reason is they use streaming, streaming like in a movie, go from the beginning to end. And if you don't follow the streaming path, then the memory needs to load extra additional information, and eventually it can't handle anymore because you're basically handling in a browser, and the browser has a memory limitation. Think of it as Netflix or Amazon Prime. You're watching a streaming movie, and you can pause it. That's not a problem. You can forward 10 seconds or 2 minutes. That's not a problem. But try to forward and back and forward and back and pause and forward and forward and back and forward and pause. Eventually, it will crash, because that's how it's been designed. It's been designed to stream in a contiguous way, and we don't, and that's why it doesn't crash. And the reason it's, technically speaking, we have a predictive algorithm. As you move the mouse, it frees up an area, a memory area, and then loads the next. So it doesn't freeze. It just continuously loads and unloads and loads and unloads. Anyways, here you can see regions of interest. You can create annotations here. You just move it to the area where you want to make an annotation, and we can have here test 55, and I have no idea, and you mark here if this is from a red cell, from a band, neutrophil, whatever. So you tag it, and then you save it, and then this has been saved as a region of interest, as an annotation. You can then later export those annotations, then you can query, analyze all those. You can also make measurements, compare two slices, export the image, etc. So let's say, going back to the narrative, you saw a radiological report, you saw there was a tumor, and you opened the pathology. You saw that you saw the tumor, you saw the pathology report, you saw the cells are inflamed, then you go to genomics. Now, in genomics, we have the report in the same place, which is super important. You always find things in the same place, and the visualization in the same place. Now, this visualization is not image, because genomics, is not sending you image data. It's sending you data, letters. The point is, there's a lot of data in genomics, and that's why we have two different platforms, two different ways of looking at it. One is the complete one, if you will. One is for geneticists. One is the specialist that needs to fine-grain looking at many details. This is a screenshot. I'm not going to do the demo right now for you because, again, that takes a bioinformatician, which I'm not, and also a lot of time. And so to keep it short, I'm going to show you what it looks like. In this case, you're looking at a lot of filters on the left. And then you have here the information of the specific case that you're looking at. And the case could be a patient, family, cohort, population. And then you're looking at variants, at genes, types, annotations, and family tree, the population occurrence, and the prediction, the interpretation. But again, with many filters and predefined in silico panels to make it easy to look for things using natural language, using ontology. For example, is there any relation in this patient between his asthma and breast cancer? Well, I don't know, sounds ridiculous, but I'm not a geneticist. Maybe there is. So I could type asthma and breast cancer, and the system will focus on those areas. That way, we can make next generation sequencing, whole exome, whole genome, whatever, as easy, quote unquote, to use or as understandable as individual panels. But anyways, in the platform, the other view we have is for non-geneticists. So you're an oncologist, or you're a neurologist, you're a cardiologist. You know that genetics is important, and you know a few of the genes and the variants that are more often related to specific pathologies, but that's all you know. So you don't want the super complicated platform. So this will be the simplified one. We identify patients here by number instead of name, like the other areas. The reason is, and you can see this is the same number. The reason is you could have a family case. You could be looking at more than one patient. And another reason is genomics has particularly strict privacy concerns. Who is the real father kind of thing. So sometimes you don't even want to show the name. So, but we do need to identify the patient. So here we have the correlation between the patient number and this sample number. These are basically the steps. The identification of the sample, 2 quality controls, and sample coverage. In genomics, there's a lot of uncertainty, a lot of new discoveries, a lot of bad practices as good as good practices. It's a lot less standard than radiology and pathology. For example, there's no single standard for the format, the data format. There's not a single way to find information. There are many what are called pipelines. So you got to be extra careful with the quality of the data, because if you're going to give a clinical assessment, a diagnosis, treatment, whatever, you need to make sure that the minimum quality standards or procedures are covered. So, for example, in the coverage, there are areas where it falls below the minimum required coverage, and therefore you should not be reporting on those areas, or you should be reporting careful this doesn't go above the minimum threshold. In any case, quality control, summary, and report. You can just download the report and be done with it. You can download the data in the different formats, and you can visualize. What you actually visualize, you visualize filters. And like I said, this is after the big platform. The big platform is going to crunch through all the genomic data. It's going to go through all those filters. It's going to do all that processing. This is what comes after. So they only send me 90 variants. There's, probably tens, hundreds of thousands. It doesn't matter to me. This is what the geneticists found relevant. So I can go through them and say, okay, yeah, there's still 90 too many. What I know is that I want to see pathogenic one. I know it's important. I can say in which databases, I can say, which functional consequences, but I'm just going to focus on something very simple. One simple filter. It goes from 90 to 9. That's more manageable. And then I can look at the list and say, oh, KRAS, this is my foe. It's always KRAS, because I'm looking at a lung cancer, or what used to be called lung cancer, and now is a KRAS positive, whatever. So once you select it, you see a lot of information. You see details on that one. You can see the predictions, or is damaging, the databases where this information came from, the specific anatomic region. So large intestine. Okay, this is pretty significant. You can see the raw data if you need it for whatever reason. I don't imagine any clinician needed the raw data, but there's an easy way to access it. And very important review. As clinical genomics is constantly evolving, consensus can be challenged, can be questioned. For example, specific populations can have endemic variants that might not have the significance that it might have on other populations. So if you encounter those inconsistencies or that uniqueness, you can annotate it here and save it. So you save the annotation. But in any case, we're going to keep it simple. We selected this one, then we go to the relevant variants, and same information down here. We just click add it to the report. Paréntesis para el comentario. Tienes variantes relevantes en informe, pero si pones lo de informe en variantes, no hace falta ir a relevantes, pero bueno, da igual, pequeño comentario. So then you marked it, and you go to the report, and in the report you just fill a few fields. A lot of information is going to be added automatically. So all the information that we saw before when we clicked on it, and you add the interpretation. This can be all this patient information type of material. This could be automated if it's connected to the laboratory information system, if the genomics department uses one, but if not, you can enter it by hand. And then you have pharmacogenomics. Once all that process, all that journey has been analyzed, has been done, then the last step is finding out what medication may or may not work better for my patient, for this patient with specific variants. So here what we do is we load a list of variants, the short list that we saw before, and we can select which database sources, which gene categories, interaction times we want to look at, or we can load medications that we're considering administering to the patient or we're giving to the patient, and then the system will look at many databases for those variants, for all the medications that are in the database, and will give us first a summary. So here see a table with all the databases, the sources, and then the scoring. But obviously there are many variants here, and we want to focus. So then we go to the detailed results. We look at FLT1, endothelial growth factor. It affects colon cancer. We're seeing that all of these are inhibitors. We need an activator or an antagonist, and then we order it by interaction type and see that the first one in the list for antagonists is sunitinib. We see the source, we can click on it and see more information on the gene, on the variant, on the medication. But this is a 3-click pharmacogenomic solution. Not the only one. We can do it in many different ways, but that's a simple one. Now, each one of the steps that we've seen coming together has its own different workflow. So, if you're a radiologist, if you're a pathologist, you have your own workflow. If you're a radiologist, first the patient schedule, unless it comes in through an emergency. So we have a scheduling. Again, our scheduling solution is very similar to others, so I'm not going to go into details. Then you have a technologist work list that lists the procedures to be performed connected to the multimodality work list. Then we have the radiologist table and work list. There are two that show the same information, but in a different way. And the reason is many radiologists are used to work with old RIS. First, it asks you which is your favorite workstation, if you haven't said it before. So all RIS in the market look the same. They're like spreadsheets. So many radiologists like this view of give me a table, which is fine. Then we give radiologist table. From here, you can do everything. You can see all the studies. You can see them organized by any of those columns from different locations, color-coded. You can see the preview of the images. You can launch the viewer. You can launch on the workstation. And you can mark it differently, as critical. You can edit the report, hold it, dictate it, change the status from here. You can do it also from here. You right-click, and you can set the status, set the priority, view the appointment, with the information for the patient. So from here, you can launch everything. Now, the issue with this view is that it's too full. If you ask me, it's too full. There's too much going on in here. And that is a particular problem, which is it causes stress. I'm seeing here studies that have been reported, studies that have not been reported, studies that are urgent. Everything is there. And I don't think that I want to be subjected to all that information at all times. It's confusing. So we created this other view, which some of our clinicians prefer, which is much easier. There's only one thing in that list. Why? Because I have a filter. If I am the emergency radiologist, I only want to see emergency radiologists. I don't want to see prenatal ultrasounds. In the table, you see it because it shows everything. Then you can order it, but it still is there. It's thousands or even hundreds of thousands of studies there. Here, there's only one, or there's only 10, or there's only, whichever I need to pay attention to. So that's why we created this view. In any case, same thing. You have quick filters down here. Say, I want to see only studies from today, only studies from my modality, only studies assigned to me. So you can have quick filters. You can have your own filter. And here you can select per status, per room, per patient, whatever, so you can search. You can, by the way, if you don't know what some of the icons are, you have their icons all over the built-in information page. It's very useful because you don't have to look at a manual video or text. It's built in, and it has here all the icons and buttons explaining to you what they are. So in any case, when you have selected the study you want to look at, you have different ways to report. You can record an audio, and it will send the recording directly to the transcription service. You have to enable it, of course, haven't. You can see previous reports or reports that are pending signature. You can see keywords, or you can use a traditional word processor and use templates. So you can load a template that will add a lot of information automatically from the metadata of the DICOM. You can select key images, and you can add the report here for then it being signed or authorized and signed. Sometimes there's a double step, so all those can be configured. You can see comments if somebody made a comment, like the technologist made a comment or reception made a comment, or if there's an additional file that's been added, like the scan of the request or whatever. And the same as the other view from here, you can sign and mark it critical, return it, return the transcription, view the order, see the images in the viewer, see it in the workstation, print it, look at all the studies or link it up manually. So that's the workflow for radiologists. Every single different ology has its own workflow. For example, in pathology, it will start at the scanning level. So if you're a technologist, you're going to be scanning. So here you see all the slides have been scanned. There is one that gives you an error. Then the rest have been processed properly. Again, many icons, so we can click on this and see what all those icons mean. And then what we really want to do in this page, other than seeing if there's any error, it's check the metadata, because digital pathology scanners are not, like I said, they don't use DICOM, therefore they're not DICOM nodes, therefore they don't add standard metadata to the slides, therefore you may want to check or add or correct. So for example, which patient does this belong to? In theory, it's going to be linked automatically via the barcode. What kind of slice is this? What kind of, who's the referring physician or the lens capture? What is the usage? Is it for teaching, for clinical, for research, for molecular tumor board? You can change those, and then you can anonymize an area of the slide, because sometimes pathologists will write things on the slide, and you have to physically remove parts of the image. So that would be the technologist in the lab in pathology. And another thing that many technologists do is they have to create cases. So here we have a list of cases that have been ordered. So first it has to come from an order from a laboratory information system. And then what this allows you to do is to combine slides with slides that can be already scanned, or that might need to be scanned. If they need to be scanned, we can select if they need a label. Loading, usually it does load. There was one with the slides. I can't find it. In any case, you give it a name. It has an ID, internal and external. You describe the block and say how many blocks it has. And then each block has a number of slides. Blocks, cassettes, you can be organized by different levels. The new version will have a picture of the macro of the tissue of the sample. And then once you select the slides, they show here. And if they've been scanned, those are the slides. If they have not been scanned, then it gives you an option to select which kind of staining and if it has a label. So you can print the label, and then the scanner will know which patient does it belong to. Once you have the case created, then the pathologist will review the case, and same interface for creating the report with voice recognition or dictation or templates, etc. We now have synoptic reporting. It's going to be introduced in the latest version. This is what it looks like. Synoptic reporting is a funny term because structured reporting was already taken. So, but it should be called structured reporting. Basically, what it does is it doesn't allow you to enter free text. You have to select from specified ranges, specified terminology. So there's less inter-report disparity, and it's more homogeneous. In any case, this follows the College of American Pathology templates, which for the last 2 years have been a requirement when a lab requires US or international accreditation. So this is built in our latest version. And then all the tools, other than, each clinician has its own workflow, and we can go over the workflow in detail. Some tools are useful, like the audit log and orders and stuff. One particularly interesting is the dashboard, because the dashboard, depending on how it's configured, it can help administrators, it can help clinicians. It's very useful. So basically what it does, it presents information from the system. It can be, for example, we have a summary here. Let me give it a time range so it shows more interesting data. We say refresh. So you have a time range and a number of items that you want to analyze. So how many studies per modality, appointments per status, how many patients have been waiting for more than 5 minutes, how many, the time between patient arrival and creation of the study per modality, or appointments per referring physician. All this information allows you to manage your resources properly, and it can be either seen on the screen directly in real time, basically, or it can be downloaded. You see the little spreadsheet format here, or it can be sent via email. So you just say, what's the range I want to view it, or I want to send it via mail, daily, weekly, monthly, yearly, to whom, copying whom, even blank copying whom. And then this will generate a regular report that you will be receiving via email without having to worry to go into the dashboard. So like I said, there are many other elements, orders, list of reports, external scheduling, uploading samples, managing the orders, the nursing data enter. But basically, this is an overview of our platform. So if you have any question, let me know. Y ahí es donde para la demo. Eso es lo que digo y eso es lo que muestro. Siempre lo mismo.